Hello guys, I've heard you like some dirty pointer talk, and that's exactly what we're gonna talk about today. So, here's the thing. Pointers are pretty difficult, and C++ uses them quite a lot. There are situations in which you can avoid using pointers, and situations in which it's fairly difficult to avoid using pointers. So, what we're gonna talk about today, essentially, is how C++ thinks about pointers, but in a little bit more detail. And let's demystify pretty much everything, well, not everything, let's demystify a lot of what pertains to pointers and functions, and how functions copy stuff and how functions don't copy stuff in C++. How about that? So let's start with a simple example. So let's create two variables. I'm going to create a variable x with a value of 10 and a variable y which is equal to x, right? So without further ado, let's see what we see on the screen if this were to happen. Well, guess what? Nothing too surprising over here, but okay, let's just run this one a little bit, and we have this output. Now, here's the interesting part. What if we were to change the value of variable x just after we've initialized variable y with a value of x? See, I'm saying value. So, as you might expect, we're going to have two different values over here. Check this out. So, why does this happen? Essentially because in this point over here, C++ actually creates a copy of x. It doesn't state that variable x and variable y are the exact same thing, right? And how can we verify that? Allow me to demonstrate. So, if you want to see the address of a variable, we could just go ahead and write this. Address of x. Check this out. I'm gonna, instead of just writing x and a new line here, I'm just gonna put an ampersand in front of the x variable, right? And I'm gonna do pretty much the same thing for y. Let's give this one a run and see what pops out. So, what can we notice from here? Well, basically, these are two different addresses in memory that we have for variable x and variable y. Essentially, because we have two different addresses in memory, well, it makes sense that they're different, right? Now, here's the thing. Where does it get complicated? I'm just gonna write a cout over here and print a small line over here, and I'm gonna create a function which is gonna be called modify parameter, and I'm gonna give it a number parameter, and check this out. Whatever would have been in the parameter value, I want to change it. I'm gonna go ahead and write, let's say 9999, basically, right? So let's go into main, and I'm gonna create another variable. Let's call this one z. 41, and I'm gonna go ahead and write this. The value of z is, and I'm gonna display z. Well, nothing too unexpected over here. 41, as we would have expected. But what if, before displaying this line of code, what if I were to invoke modify parameter and give it z as a parameter, basically? So what would happen here? Would we have 9999 or would we have 41? I'm gonna give you a short moment to think about it, or you can just pause the video. Who am I to tell you what to do? But check this out. This will have absolutely no effect on the value of variable z. Check this out. We might have expected it to be 9999, but as you can see, it's not. It's still 41. Now, why did this happen? Because C++, when it has a method, a function, that takes a parameter, it actually creates a copy of it. Check this out. How can we test this out? I'm gonna go ahead in main and write like this, address of z. And I'm gonna put a quick ampersand just before variable z. And I'm gonna go inside the modify parameter function, and I'm gonna do the exact same thing, address of parameter number. And I'm gonna put an ampersand just before it, right? So let's give it a go and see what happens. We would have expected them to be identical, but they're not. As you can see, one ends in A20 and one ends in A84. Now, see, here's the thing. If they were to have been the same, now we would have seen the same exact address, right? But C++ says, hey man, it's not exactly the same. So what does it do? It creates a copy, in meaning that, in this case, number is not exactly z. It has no impact on z. It's like we have done here at line 15. So basically what we have, essentially, is a copy. Does that make sense so far? Certainly hope it does. Okay, so what about pointers? What's the deal with pointers? Let me show you something. I'm just gonna go ahead and write another line over here. So inside of main, I'm gonna create another variable. I'm gonna call this one, I don't know, let's call it A. And I'm gonna give it a value of 300. Why not? Seems pretty lucky. So what's gonna happen with A? Well, basically, let's just go ahead and display the address and the value, right? Address of A is, let's not forget to put the ampersand before A, and then value of A is, and we just go ahead and write A as we might have expected. So we're gonna go ahead and see this. See, we have the address of variable A, and we have the value of variable A. Fair enough. Well, what happens if we don't want to store a value? What happens if we want to store the address of variable A, right? Let's have an experiment. So I want to create a variable, let's say of type int, called address of A. A what? A variable. So address of A, I'm just gonna go ahead and try to do this. Ampersand A, but this will not work. Now why doesn't this work? Because see, addresses and values are two different things. In this case, address of A is declared as just an int value, basically an int variable. But ampersand A is what? Essentially, ampersand A denotes the address, right? So basically, check this out. I'm gonna paint this. So we have basically the variable A, which stores the value of 300. So excuse me, but writing by mouse is a little bit trickier. However, here's where the interesting part starts to kick off. Every variable that we create has an address, right? As we have seen, basically. So let's imagine this address is attached somewhere around here, basically, right? It's not exactly the value, but it's like if a variable is a drawer, then the address is what is written on the drawer, essentially. It's the key to the drawer, sort of. So if we were to run this code, I'm just going to comment out this part. See, when we have the address of A, see, this value over here is actually the place in memory where A is stored. So essentially, this value here, just a second, this value here is this address. I hope it makes sense. But here's the interesting part. If you want to create a variable, let's just draw this one over here, in which we want to store just this part, right? Just the address. Now, I can't create this variable as just being an int, because ints And addresses, as we can see, look not very similar, right? So what would I have to do here? Well, the address of A, see, this variable, I'm gonna declare it like int and this little star over here. And see, the error goes away. What is this saying? Well, basically, variable address of A is going to be a pointer. It's going to be a pointer. It is going to be a variable that stores not a value, but an address, right? So, essentially, what happens here? The variable address of A, this one, stores this particular address in memory. Now, what's this useful for? Well, many things, but before talking about practical uses, let me show you something interesting. So, if I were to write value of address of A, check this out. I'm gonna write just this. See? Now, take into account, address of A is not an int variable. It is a pointer to an int. It is an int address, right? So, let's give it a run. Check this out. 604, 604. It is the exact same thing, right? So, what I managed to do here, essentially, is create a variable in which I'm storing the key to the drawer. Basically, if a variable is a drawer, then what I have here is the key, right? But what could we do with a key? Because just having a key isn't fun enough, right? Let me give you an example. So, first things first. If I were to change the value of A, let's say it's 400, and I display, see, I'm going to display the address of A a bunch of times, just changing the value of A, right? Check this out. The address is not actually going to change. See? FA84, FA84, FA84. See? So no matter how much A changes, the address to it, the key to the locker, remains the same, even if we change something in the locker, in the drawer, right? Okay. One more thing. Well, having a key to a drawer allows you to, well, open the drawer and see what's inside. Where does this come useful? If I want the value of A, I could, of course, write like this, like so. So, A is what? 600 now, right? If I run this, it's gonna say A is 600, right? Yep, it will do that. However, I could also write this value of A and check this out, star address of A, enter. Let's give this one a run. Interesting, isn't it? 600, 600. So what happens here? Well, basically, if I have the address as such, right? So this whole variable points to here, right? If I have the address to a certain drawer, I could easily go inside the drawer, right? From a variable which holds an address by using this star symbol, which basically dereferences it. Does this make sense? So if you have the key, you can you can access the contents, right? Cool. But you can access the contents and actually even modify it. Check this out. Let's have an experiment. If I were to go ahead and... So, technically speaking, address of A is just an address, right? But, see, if I were to try and run this, address of A is 900. Well, this will not do. Why? Because this variable is of type address, right? Int star means int pointer. So I can't just go ahead and say C++, go to the memory address of 900 and, well, do something there, right? But I first have to enter inside the drawer, right? And check this out. I'm just gonna copy this line of value of a right after this statement. Let's see what it gives us. Interesting. It says 900 this time. Why? Well, basically, if I had the address, if I were to write this line of code, right? Address of A with the star sign right at the beginning is 900. Well, I'm not actually changing the address, I'm changing the contents to which the address is pointing. See what I mean? So this actually does what? So I have the address right about here, and I'm going inside and replacing the old value of 600 it used to be with 900 over here. Make sense? I certainly hope it does. So, what's the moral of the story? Well, here's the thing. Pointers are sticky, right? So, let's take into account the first example that we did, right? With x and y. See, in this case, C++ creates a copy of x, right? And y is a completely different drawer. But pointers, in fact, are sticky. Let's rewrite the previous example in a similar fashion. So, if I were to have x2 variable, which is 10, and then I'm not going to create a variable y, but I'm going to create a pointer variable, pointer to x2, and I'm going to give it the address of x2 actually. See, I'm storing the address, not the drawer, not the value, not what inside the drawer, inside the pointer to x. I'm storing the address, right? So I'm going to go ahead and modify the value of the pointer, but I'm not going to write this. Instead, see, I'm not even allowed to do this. Instead, I'm going to go ahead and write this. See what I mean? So what's going to happen over here? I'm going to see out x2 is x2. What do we expect is going to happen over here? Well, see, the pointer is sticky. The pointer sticks to the address. So if I were to modify the value from the address, I'm going to modify the value of x2, essentially. See, let's give it a run. And we see that x2 is actually 30 at this point. See? Also, if at a later point in time, I want to modify the value of x2, saying, I don't know, 55, for instance, right? If I want to display x2, I'm going to display it traditionally, and I'm going to display it through pointer. How would I do that? Well, let's not forget that if we were to write this, we will just see an address, right? Look. See? But if I want to take the value from the address, to take the value at which the address is pointing, I have to dereference it. I have to put this star symbol over here. See? Check this out. 55, 55. So we have not to confuse this star over here with this star over here. In this case, we're using the star symbol to say that this variable is going to be of type pointer, is going to be of type address. In this case, we're using the star symbol for a variable that already exists and is of type address to get the value. See what I mean? So this gets the value. And you can also change the value, essentially, right? Cool. I hope this makes sense. But how is this useful for functions? Well, check this out. I'm going to call this one main2, and I'm going to create another main function. Because remember, when we run the program, only the main function gets called in this case. So if I were to have a variable x again, I'm going to put here 1000. I'm going to go ahead and call modify parameter, and I'm going to give x as a parameter, and then I'm going to go ahead and write x equals x. So remember when I stated that modify parameter doesn't actually modify the parameter, it modifies a copy? Look, see? X is still 1000. It's not 9999, right? But let me show you another version of a function which would actually take a parameter but actually modify it. So can you guess what I have in mind? Check this out. I'm gonna create a function, modify parameter function that actually works. Let's call this one a pretty intuitive name for a function. So I'm gonna go ahead and write as such int pointer. So this function doesn't take a regular int as a parameter, which would have been a copy. This one instead takes an address, right? Address to something, right? So first things first, let's have an experiment. I'm gonna comment out this modify parameter over here. I'm gonna go ahead into main and write this. Address of x is, and, well, I'm gonna do what? Essentially, ampersand x. Remember that if we have an int variable, we have to put ampersand before it in order to see its address, right? So I'm gonna give it a go. So this gives us nothing too interesting over here. But if I'm gonna go ahead over here and say out the value of the parameter is address to something. See, now here's the thing. Address to something is the parameter. It's already of type address, right? The value is not actually gonna be the value of 1000 that we might expect. Instead, well, it's gonna be the address. Because look, if I were to invoke this function as such with just x, I can't. See? The problem is that when I try to feed this function, this parameter, it says, well, you just give me an int. You didn't give me the address to an int. You just give me an int. So I'm not going to work. But what must we do? Remember, like this gives us an address. Well, if I prefix x with an ampersand, see, now it's working right as rain. Let's give it a go. But what can we see? A34, A34, it is the same actual address. Interesting. Well, if this function were to modify the value that the address is pointing to, how we would go ahead and do that? Well, address of something with a star before it, because I don't want to change the address, I want to change the value to which the address is pointing, right? And I'm going to write 9999. Well, check this out. I'm going to go ahead in main and write x right after invoking this function. Remember the last version of the function which didn't work because it just made a copy? Well, let's see how it behaves this time around. Ta-da! See? So basically we have used pointers because remember pointers are sticky, right? So if I have a function that takes a pointer, takes an address, and I modify the value to which the pointer is pointing, then the change sticks. Does that make any sense? I certainly hope this does. And I certainly hope this kind of helps demystify pointers a little bit. Now, later on we're going to have some more tedious examples regarding pointers. And yeah, truth be told, they are kind of difficult, but we can demystify them step by step, right? So by the end of a lot of videos, I hope this is going to be much better. And that the pointers are going to be far easier to handle, right? So what do you think about this? Let me know in the comments. Oh, one more thing. So here's the thing. Drawings actually help. So Let's exemplify what happens with this variable with x inside main, and what happens with the parameter addressed to something inside modify parameter function that actually works. So here's the thing. We have the main function, excuse my writing please, in which we basically create a variable x in which we store the value of 1000 basically. So what happens? Inside main there's a variable x created, which actually, let's draw this as a drawer, where we have the value 1000, but here's the thing. The variable, of course, must have an address, right? So it's gonna be something attached to the variable. Each time you create a variable, it has an address, because it needs to be stored in memory, right? So here's the thing. Our function, the modify parameter function that actually works function, I'm sorry, I know it's a long variable name, a function name, takes a parameter, right? And it takes a parameter of type int pointer. So it is a pointer basically, right? It's not a value, it's an address. It's not a copy. So when we invoke this function over here from main, what happens? When we invoke the modify parameter function that actually works, sending it the address of x, essentially this function doesn't create a copy, doesn't go ahead and create another variable inside it which stores 1000. It actually receives as a parameter the exact address that is associated with the drawer, right? So inside the function, when we write, okay, basically star dereferencing the pointer, as in I want to have access to what's inside the address, to what's at the point that the address is pointing to, right? I know this is a little bit convoluted. So I want to take the parameter, take the address, and do what with it? With the value of it. I want to replace whatever was over there with 9999, right? So basically, this actually, taking into account that we're not working with a simple int parameter, but we're receiving the address of it, and the address doesn't change as we'd have seen previously, this value of 1000 over here gets replaced with 9999, right? So essentially, what happens is that after invoking this function over here from main, well, basically, the value of x changes permanently from 1000 to 9999. So when we run it, actually, we see the value being changed. This is because the function works with pointers, works with addresses that are sticky. The function receives an address, and it doesn't simply go ahead and create a copy of it, right? This is not the case. It works with the address, and the address is the same for main and our function. I hope this makes sense.